Hello everybody, it's Nick with Electro-Madness GPR. Today we've got the Proceq GP8800. And today we're going to do some concrete scanning, looking for rebar in the column here. We just laid out a nice piece of foam board. It's about an 1/8 or a 1/16 inch thick, so those of you that know concrete scanning are going to know the data is going to be a little bit different. So we're just going to account for that as we're analyzing what we're looking at. So as I intend this video to be for new people, we're going to start with a quick setup. Turn the thing on, either button on the side. It should come standard with a wheel that pops off. You gotta screw this little screw in or out depending on where the wheel's at, and just gently pull one of the sides out, and like that it clicks out. This thing is very versatile. You can use it in different applications, different polarizations. We can talk about that another time. In this instance, we're going to be using it for standard polarization or traditional. So these here on the back are usually where I like to put it. So I'm going to go ahead and set that there. Got to be very careful with these sensors, make sure they're clean. Occasionally wipe them off. And I know I'm a hypocrite, I've got paint on mine. I try to wipe it as best as I can most of the time. And get an occasional deep clean in. Let's make sure it's screwed in pretty good. I'll give Proceq credit on how they built this thing. I've never once had to worry about cross-threading these things. It looks like they're brass female threads, and this looks like maybe aluminum or some kind of steel alloy. We'll talk about that another time. So let's get going. We got a iPad here to start. It's the beauty of this thing. I'm going to pop the Proceq app open. You download it from any app store or not any app store, it's from your Apple app store. So, because it is exclusive to iPad, as far as I know. So let's get started. We're going to look for some rebar right now, and this is going to be a tutorial mainly for the use of construction. I'm not an engineer, I'm not a geophysicist, but there are plenty of great resources online where you can search for more detailed knowledge, but in this case we're just going to talk about basic applications, start and go, and what to expect when you're looking for rebar. So I'm going to turn this on by allowing it to connect via Wi-Fi. Now, some people who may have used these before have probably experienced issues with the Wi-Fi, and it's pretty similar to anything that's remote control, like an RC car, airplane, whatever you got. Sometimes the connection is not going to be consistent or perfect. You just restart it, just shut both things down, turn the app off, take the battery off. I usually like to turn the thing off before I remove the battery, just in hopes that does something. I haven't proven anything to that yet, but so far it's been doing me pretty well. So I'm going to hit start here, or you could push one of the buttons. It's just kind of getting the connection. Sometimes it's good to just do a couple quick passes. See, it's not taking the data right now. It's a little bit laggy to start. It's just kind of getting that connection. And we were using it all day. The Wi-Fi has been having a party with all our different scanners that we got. And we're coming right back to this one. So just to step out of the way, we are in a parking structure. Let's see if you can see it here. All the columns. It's my favorite training spot for post-tension, so we'll do that another time. So hopefully you got a good view. What we're going to do is, let me blow this up for you ahead of time. The view is great, but we're not going to be looking that deep. We're just looking for rebar size, spacing, and orientation, meaning the direction that it runs, and then we're going to mark it out. So all you do is you place the scanner gently on the wheel. You gotta be nice to the wheel. Not everybody is. The wheel is one of the most important pieces to a scanner. Now, a lot of people like to mark on the sides, and we already know it's going up and down, but sometimes you got imperfect rebar. So the point of collection is going to be right here, dead center, and we drive the scanner forward, so everything behind us in the data is what we drove back. We've got a yellow slider here that moves with the wheel, tracking what is right here. So right here in the screen, let's see if we can bring this up. We're looking for all that. So let me see if I can get a view here. Getting a little bit of both. I'll blow this up a little bit more. Maybe get a screen recording. Okay, so we'll work with that for now. I'm no professional YouTuber. I like to put X's for my findings and then just kind of come back over it to see. Sometimes maybe off. Perfect example of that. So I'm going to cross that out. This method that I'm using here, I like to say it's kind of like building a window for yourself. Now, if you notice, I'm staying disciplined to being nice and kind of straight against the orientation of the vertical rebar. So what I'm doing is I'm running over rebar coming up and down, and I will make my first pass on the top. Oops, drop the marker. And now I'm gonna make my second pass on the bottom. Here we go again. You got to make sure to reset your data too. If you're doing line scanning, you're gonna have to do that a lot. Alright, so we really only have two pieces of rebar here in the front. We're not scanning all the way through the beam, because most times you can't really see all the way through. Sometimes they're a little bit more dense. So now that we kind of know that these are our lines, I'm going to put these here so that we remember they run up and down. Reset the data. And just like I said before, we're building a window. We did the top, we did the bottom, and now we're going to do the sides. But this time, we're looking for horizontal rebar. And they're going to be a little bit thinner, so you got to be, if you're trying to avoid rebar in the construction, the job, or analysis of what you're doing, you got to be really careful with these stirrups, as they call them. They're a lot skinnier most of the times, so your accuracy should be, as always, your accuracy should be better than a large object. Only because you can almost completely miss these being so small. A larger object, if you're off by a little hair, realistically, we're going to draw over it with a pretty fat mark out as it is. Most of the time, the recommended size for the markouts are about the size of a level, when realistically the bar is probably only about a fraction of the size. So, but these vertical ones, they're pretty big, so we're gonna just go with a little bit wider, of a mark out. Standard practice is to go dead center with your line. I'm gonna go a little bit out on these ones, just because we know that since we've been here before, we're going to just kind of eyeball the size of what it is. I'm going to stop at the tape because it should be a good standard practice to mark all your borders. Okay, just come up a little bit. In these cases, especially being new to the industry, it's better to be safe than sorry. You don't want to undermark something or incorrectly mark something. You would be better off marking it a little bit bigger than it looks. You know, if you're uncomfortable, if you're extremely uncomfortable with your marks, mark it a little bit smaller. Drawing a fucking blank right now. Mark it a little bit bigger. That's how you want to do it. So because I know that this one is probably about the size of the marker or even smaller, I'm going to mark it almost the same size as if it was my first day on the job. So we'll go with this size. Make sure it's lined up. Those ones are a little bit weird. Nice solid lines, so I'm going to bring it over. I'll show you why I'm doing it in this order in just a minute. Now that we know our vertical bar is handled, we can double check the findings, because this one was kind of close, so we don't want to be off on that. It's off by a little bit. And that's most likely because when I took the data, I was running over this rebar here, so it's always good to double check your work no matter what you do. Doesn't matter if you're making pizzas. I used to make pizzas, and up a little bit, and always double check your pizzas is what I was going to say. So that is about it. I just moved the damn foam right now, so I'm just gonna pretend like that never happened. I'm gonna draw this thing out just kind of standard size. Getting used to it, you can get different tools for marking. And you can get smaller levels or straight edges and use that for different size bar. And I'm going to show you what I'm doing here. I'm not doing the outsides for a reason, because as a column, the rebar doesn't continue outside the column, so we're going to do a little trick here. Called running over the rebar. Center with the bar, running with it. It's a little bit weird because you're gonna see a line. This white line right here is your rebar. Now that you see this white line, we are going to do a quick comparison for those that like to verify things like this. I just ran over it and went back. You kind of see that. Now if we tap right here, we can see the depth, the estimated depth, and that green line is lining up just about with the top of that hump. And this data set here is us running over the rebar, parallel with it, on top of it. So now that you know what that looks like, we're gonna look for the end of that. Take it as far as it goes until it ends, just right about past the rebar, the vertical rebar. So that ending there, right about here, shows the end of the rebar. Now you might wonder, why is it tapering down? That's part of the science by the signal kind of reflecting downwards off of the material the best way to imagine it is like if you're spraying water on top of this, it's not going to go straight down, it's going to kind of fray out. That's how a radar signal works. I would love to be corrected otherwise, but you know, I'm just a knucklehead laborer and it works for me. Like I said, there are plenty of videos out there by true professionals with PhDs, geophysical degrees, and the full works. Who can speak a lot better than I can, but this works for me. And knock on wood, no hits in a long time. There you have it. We just marked out some rebar here, the basic outline of what's inside this picture frame. So if this were to be a job for another customer of ours, ideally you should label what you find. I know you probably don't want to do it for every finding, and some people might think, well, that's obvious, it's rebar. Like, who doesn't know rebar is inside of concrete? But you got to treat your customers well, and not that you're dummy-proofing your work, you are just pretty much allowing something to be viewed with little effort of understanding. You don't want these, you want to prevent as many questions possible. Just make it as easy and seamless for them as possible when they're going to be performing work after you. It's a courtesy that I'm sure anybody would appreciate. So usually I label most of my rebar, at least in most areas where it's visible. Especially if I'm going to be taking pictures, I make sure everything in the picture is labeled. So we can put depth with these too. I'm going to do a quick tap on the screen here. So we're just going to backtrack on this. So remember, we have that line that we ran over here. This is the perpendicular pass. It's about an inch down. It's not recommended to put the exact depth, but you can put plus or minus. You can put the about sign. This is that same rebar here. We're just going over the video, just checking that one rebar so many times. All right, there we go. Vertical bar. So the first one was about 1 inch. This one is about 1.7 inches. There's something very important that I'm going to show you in this video. I'm not going to get super technical, but the one thing when doing depth calibrations that you need to take away, it's called hyperbola matching. These settings here under image processing, we have dielectric constant, and when we hit that slider, it creates this image here. So I'm gonna pause it because if you accidentally push the wheel, it's gonna go nuts. It's kind of stupid, but go back. There we go. So this is a hyperbola. They call it hyperbola matching because they give you this image to put right on top of it, and you want to get it as close as possible to this so that it matches the one on your screen. So we're just ballparking this one. It's not super critical, and it's a lot easier to do when you're on a slab that you kind of know the depth. That is called ground truthing. So we'll talk about that in another video. I'm going to get back to the scanning, go over the horizontal one here. See how the depth changed? (1.2). So if it mattered, then thank God we did it. I'm gonna go over the vertical here. So remember, left vertical and then right vertical. Probably gonna be the same, about 2 inches. We're gonna pretend the customer said, I don't care about the depth. I just want a ballpark. I want to know just kind of generally where it's at. So I'm gonna put about 1. You can put decimals wherever you're from, however you want to label your depth. I'm gonna put 1.2 inches. I like to put an arrow down because it eliminates questions. Sometimes a common question is that the diameter? And no, it's not. If it was, usually I write the word diameter, but I don't usually do too much of that. So that one was about 2 inches down. Same thing here. Now we can get more in depth with the 3D, finding the back layer of rebar, maybe some potential mid-layer rebar, get into the limitations of what we may not be seeing. Sometimes there's conduits in here. But for now, we're just worrying about the front layer, the means and methods of finding just what's in the general area of the near surface, because we could definitely get more in depth about thicker concrete, but that's very complicated to train somebody new on. So we're just going to stick to the front layer for now, how to locate it, line it out, label it, and if you want to get fancy, you can draw a couple hashes, kind of make it look like an actual rebar. People love that. Makes it look like you care about your job, which you should. It's a safety-based job. You got to be very quality oriented. Finish that up. There, look a little bit like rebar. If you want to eliminate more questions, add some arrows to it, because some people might wonder, is that where it ends? They may never know a single thing about rebar, about concrete, construction. Could be the guy's first day on the job, so you gotta almost treat every job like that. Even if they're being pushy and they like to say, you know, you don't have to do all that, and that's fine, but you're getting paid to be there, and most times, you know, you're finishing early anyways. It's a pretty good business where that's kind of the case. So what I'm doing now, I'm doing a different color. This is my scan boundary to show that everything within this area has been scanned, and if it's in your company's policy to guarantee your findings, then this would be the area to do so. So if there's any damages or missed items and the customer's pissed and he wants to sue you over something, then you can say, well, it was outside my box. I didn't scan that. Or maybe, hopefully not, but maybe it is inside the box, and that's where the customer is going to have the upper hand on you. So you got to be careful how you box your stuff out. You always got to double check your work, especially on elevated slabs, known conduits, maybe some unnecessary areas. You don't want to exactly box all that stuff out, just because it's more risk, and you know, you're almost essentially being like an insurance agent for your customer on his job, so, or her job. They're essentially purchasing insurance on their job because they don't want to hit any hazardous items. If there was a conduit in here and somebody drilled through it and shut all the lights off, or even worse, they hurt themselves, damage the equipment, and now have a lawsuit from the building that they just damaged. Whose fault is that? The person who missed the conduit in the box and didn't mark it out, maybe was rushing through a job or didn't know what he was doing, but thankfully now, hopefully you know what you're doing to find the basics of rebar, the basics of how to check for things that are unknown. We'll talk later in another video on what it looks like to find a conduit. If there's one running through here and it's too difficult to find, maybe how to structure your paperwork on the limitations of your findings, how to view in the data set what your limitations are. Because in this case, maybe our second layer of rebar is just simply too deep to find. Luckily in this case, we got one here, and I'll actually show you now. There's one somewhere in the center. I'll go up here so I can keep the pretty picture. It's a little bit blown up, but that hyperbola down on bottom is either the mid layer, most likely it's the mid layer, judging by the size of this column. Let's get that drawn out. You made it this far, might as well draw it out. Let's get this thing set up. Up, 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 up. There we go. Some companies like to color code the layers too. You can do the top layer and say like pink, blue. Don't do green. Green is associated with go. You don't want somebody to go on top of hazardous items. So not green. Just keep it close to like black, blue, purple, whatever's available to you. Personally, I don't really like to color code, only because I'm not an engineer and I don't like to get anywhere close on giving permission to drill through rebar. That's the customer's responsibility. That's why I stick to labels. I let them use their best judgment on what works and what's okay with their customer. Because just because you say it's okay doesn't mean that it truly is. Unless you want to put a stamp on something and call it good after that. But in this case, we're just gonna finish this off. We'll call this one back rebar. There you have it. Just got our front rebar here.